Well, let us see what is the next best thing that Blender has to offer us. With that being said, and let me show you what I have prerequisitely done here. I have created a blue monkey, and in the material properties I have went on for the transmission full, and roughness has been reduced to 0. And now we will see in the render properties the performance option. Threads. How many cores do you want your CPU to work on? Now what I am doing is I am changing from GPU to CPU rendering, and here when I start render, now here is auto detect. What it automatically detects is how many cores I have, and it completely uses it. Let me switch off this progressive refine and show you how it does. There are 8 cores in my CPU currently, that's why 8 boxes are being rendered simultaneously. Auto detect does that. It completely finds out how much cores that you have in your CPU, and it is going to utilize each and every core. Now if I come over here and use fixed and type over here 4 cores, I have 8 cores. Now if I type here 4, and now if I render here, my Blender will be using only 4 cores for rendering. Let me keep it in auto detect. Now the tile size. There are 2 types of tile sizes to be remembered, one for CPU and one for GPU. Smaller tile sizes are good for CPU. And larger tile sizes are better for GPU, because on CPU, let me put both of this value on 32, and these must be in multiples of 2, doubles of 2, doubles of 4, doubles of 8, doubles of 16. So means 2 plus 2 4, 4 plus 4 8, 8 plus 8 16, 16 plus 16 32, 32 plus 32 64. In that way, CPU, now it is CPU, and if I render this image, the CPU will be working faster on smaller tile sizes, whereas if I take GPU and I am increasing this size to 128 pixels and render image, GPU will be working faster on larger tile sizes. There is the order, how do you want to render it. It's not going to affect your performance in any manner. Hilbert spiral, it starts from the middle, from bottom to top. From bottom to top, do you want to render it? Let me show you one example. From bottom to top, it is going to render the bottom line first, and then it is going to render accordingly to the top. From top to bottom, from left to right, from right to left, and from center. Let me keep this from top to bottom, and then we have progressive refine. If I now render the image, you see it is rendering each and every tile and each and every block. Now what progressive refine does is, if I tick this on, and now if I render it, it will suddenly show me the output of the image and try to render it slowly, and it will be rendering in the background. First it will show you the entire image, and then it will progressively refine it. So that's why this is progressive refine. Acceleration structure, this is a part which is based on NVIDIA's paper on BVH. It's completely out of my mind, I don't know how to explain it. It's a little bit technical, so let us skip this part and go to the next part. Jump to the next section. Final render, save buffers. Now if you come over here into the edit and into the preferences, and here in the file paths, under temporary files, you can locate your renders to this place temporarily. So next time if you render it, whatever the scene, if the scene is very huge and the build up time for that render is too much, you can save that build up time by clicking this button and saving it as buffer. What it will do is all that build up data it will save on our local disk, and next time if we render it, it will reuse that saved file from the temporary path and render faster. For faster renders this is useful, and it requires less RAM. Persistent data, this is useful when we are having a slow movement of architectural renderings, where the change in the environment is not that much. Architectural rendering, what is the change in that? Hardly any changes will be there. The furniture or the tables won't be moving a lot. In that kind of scenes, persistent data is useful. What it will do is it will take all the texture inside and save it in a RAM, and then when we render it, it uses that textures from the RAM and render each and every frames fastly. So there is no build up time for each and every frame rendered. The build up time will be only once, and the rest of the frames will be easily rendered because the textures are loaded in the RAM. That's it. That's this persistent data. The next option is viewport. How do you want the viewport to be viewed? Now it is automatically using the viewport pixel size. If I reduce this to 2, the pixel size will be reduced, and if I reduce this to 8, the pixels will be very big pixels. This is for faster workflows. We can work faster in the 3D viewport. When you have a very huge scene, that time this parameter comes in use, and start pixels means from when it should start. It was a very long journey over here, so I hope you are liking this video. If you like this video, hit the like button, hit the subscribe button, hit the share button, hit the comment button and leave a comment. And if you want, you can donate money on Google Pay, Phone Pay, Paytm. Phone number will be given in the description. And if you want, you can support me financially through Patreon's page. Links will be given in the description as well. With that being said and done, try to see it, learn it, understand it. I will see you in the next video.
Veda.